Let's start where everything began 4.5 billion years ago. Earth was a fiery ball of molten rock spinning through space. Meteorites slammed into the young planet, heating it like a furnace. Volcanoes erupted endlessly, releasing gases that formed the first atmosphere. Lightning flashed across skies, striking a chaotic, primordial landscape. Somewhere in this chaos, the ingredients for life were gathering. Carbon, hydrogen, oxygen, nitrogen, life's building blocks collided. Tiny molecules danced in shallow pools like a cosmic chemistry lab. UV light and lightning sparked reactions, creating amino acids. These acids are the basic building blocks for proteins everywhere. In 1953, Stanley Miller recreated this chaos in an experiment. Miller's experiment showed life's ingredients could form spontaneously. But Earth didn't just cook once, it got hammered repeatedly. Between 4.1 and 3.8 billion years ago came the bombardment. Thousands of giant asteroids struck, some delivering water and organics. Each impact reshaped continents, oceans, and the atmosphere. Yet somehow, pockets of stability survived, allowing molecules to interact. Scientists discovered ancient zircon crystals from 4.4 billion years ago. These crystals proved Earth's crust formed surprisingly early. Stable surfaces meant oceans could exist long enough for life. Water covered the planet in shallow seas full of reactions. Life first emerged in these oceans as fragile, microscopic entities. Hydrothermal vents on the ocean floor created energy-rich oases. Extremophiles today thrive in boiling acid and deep ocean vents. These hardy organisms hint life could survive in alien environments. Life likely started as simple RNA strands copying themselves. Over millions of years, RNA evolved into more complex DNA life. Cells formed as tiny compartments protecting their chemical reactions. Photosynthesis evolved, converting sunlight into chemical energy. Oxygen began accumulating in the atmosphere 2.4 billion years ago. This great oxidation event poisoned some life but enabled others. Multicellular life appeared roughly 1 billion years ago, opening doors. Earth's climate fluctuated dramatically, including a complete freeze. The snowball Earth hypothesis suggests the planet was covered in ice. Life survived in tiny warm pockets, like thermal refuges. This resilience set the stage for the Cambrian explosion. Suddenly, life diversified rapidly with complex animals and new forms. Predators evolved, ecosystems grew, and oceans became a battlefield. Land plants colonized continents about 470 million years ago. Forests emerged, stabilizing soil and creating oxygen-rich air. Amphibians and later reptiles ventured onto land, defying limits. Dinosaurs dominated for 165 million years until an extinction. Mammals and birds rose in the aftermath, exploiting new niches. Early humans appeared only 2.5 million years ago, a mere blink. They learned fire, crafted tools, and began altering the planet. We now explore Earth and space with satellites, probes, and AI. Scientists study extremophiles to understand life's resilience limits. Some microbes survive in near-boiling water and highly acidic lakes. This hints life could exist beneath Mars' crust or Europa's oceans. Organic molecules on meteorites show life's building blocks travel. Simple chemistry can lead to surprisingly complex molecules. Hydrothermal vents act like natural laboratories creating energy gradients. These vents produce amino acids, sugars, and nucleotides. Zircon evidence suggests water oceans existed for 0.4 billion years ago. Energy from impacts and lightning drove complex prebiotic reactions. Life's origin may be more inevitable than we once imagined. RNA molecules acted like tiny programmable machines copying information. Primitive membranes formed, creating the first cellular compartments. These compartments allowed chemical reactions to persist and evolve. Natural selection operated even on molecular scales, favoring stability. Photosynthetic microbes gradually oxygenated the oceans and atmosphere. Oxygenation eventually poisoned anaerobic life, forcing adaptation. Snowball Earth events tested life's resilience and resilience. Life's ability to survive extremes informs our search for aliens. The discovery of extremophiles expands the definition of habitable zones. Boiling acid pools and radioactive waste host thriving microbes. Life adapts to niches we once thought were uninhabitable. Early Earth was a laboratory, experimenting with chemistry and survival. Every asteroid, volcano, and reaction contributed to life's story. Modern Earth bears marks of these ancient experiments. Zircons, stromatolites, and microbial mats act as geological evidence. Even catastrophic events created opportunities for life's ingredients. From tiny RNA strands to complex mammals, life's story is persistent. Fast forward 1 billion years, and photosynthesis changed everything. Tiny cyanobacteria began converting sunlight into chemical energy. This process released massive amounts of oxygen into the skies. Oxygen was toxic for many existing anaerobic organisms back then. The Great Oxidation Event occurred around 2.4 billion years ago. Vast amounts of oxygen flooded the atmosphere and the oceans. Many species vanished as the planet's chemistry violently shifted. Life had to adapt or perish in these newly oxygenated seas. Some microbes evolved protective enzymes to survive the toxic surge. Others retreated to oxygen-free niches deep in ocean sediments. Oxygen also allowed for new metabolisms, producing much more energy. Cells became efficient machines capable of supporting larger structures. Fast forward millions of years, and eukaryotic cells emerged. These cells had nuclei and organelles acting like tiny factories. Multicellular organisms eventually evolved from cooperative cell colonies. Around 600 million years ago, the Ediacaran period arrived. Strange, soft-bodied organisms appeared unlike anything alive today. They looked alien with fronds, discs, and quilted bodies. No predators existed yet, so these creatures could survive easily. Their fossils tell a story of experimentation before the Cambrian. The oceans teemed with soft, slow, and unusual forms of life. Fast forward to 540 million years ago, the Cambrian explosion began. Life diversified rapidly with shells, skeletons, and new body plans. Predators evolved, creating an arms race of speed and defense. Complex ecosystems formed with niches from the seafloor to open water. Meanwhile on land, algae and fungi started colonizing moist soils. Plants evolved roots and stems, stabilizing soil and habitats. By 470 million years ago, forests began appearing on continents. Oxygen continued rising, enabling larger and more energetic life. But life faced catastrophic setbacks during 5 mass extinctions. The Permian-Triassic extinction wiped out 96% of species. Nearly all marine life vanished in the deadliest event recorded. Survivors had to adapt quickly to a harsh and changing world. Dinosaurs would eventually rise in the wake of these disasters. They dominated the Earth for 165 million years as apex predators. Mammals existed but remained small during the long dinosaur era. Mass extinctions shaped evolution by clearing niches for innovation. Then 66 million years ago, an asteroid ended the dinosaur reign. Mammals exploded in diversity, filling newly opened ecosystems. Primates evolved with traits favoring intelligence and social behaviors. Early humans appeared only 2.5 million years ago in Africa. They learned fire, stone tools, and communication over generations. About 74,000 years ago, the Toba supervolcano erupted. This single eruption nearly wiped out the entire human race. Survivors endured harsh climates and drastically reduced resources. These bottlenecks shaped our genetics and human resilience strategies. Humans eventually spread globally, adapting to deserts and tundras. Agriculture emerged only 12,000 years ago, transforming societies. Civilizations formed alongside domesticated plants and animals. Early technology advanced from stone tools to bronze and iron. Cultural innovations like writing and art connected distant societies. Each evolutionary leap is built upon chaos, adaptation, and experiment. Oxygen, mass extinctions, and crises are recurring catalysts. Humans today carry echoes of these pressures in our genetics. Life demonstrates astonishing persistence even under extreme stress. Each stage, from microbes to humans, highlights persistence. Fast forward to just 2 million years ago, early Homo emerged. They walked upright, used stone tools, and explored Africa's landscapes. Brains were growing larger, enabling planning and social interaction. Around this time, Homo erectus mastered fire and hunting. Fire changed life completely, providing warmth, cooking, and protection. Then 75,000 years ago, symbolic behavior began quietly appearing. Early humans painted caves with ochre and created shell beads. These actions show the first sparks of imagination and culture. Campfires became centers for sharing stories, strategies, and bonding. Communication improved survival and spread knowledge across generations. Around 60,000 years ago, Homo sapiens began migrating from Africa. Small groups spread across continents, encountering other hominids. Interbreeding occurred, contributing Neanderthal DNA to modern humans. Some populations also carry Denisovan genes, shaping immune systems. This genetic inheritance helped humans survive new climates and diseases. These migrations set the stage for settlement across the globe. Stone tools evolved into blades, scrapers, and hunting instruments. Cultural complexity exploded with music, ritual, and symbolic objects. Homo sapiens demonstrated cooperation and innovation unlike other hominids. The genome shows interbreeding left marks influencing us today. Neanderthal alleles affect skin, hair, and susceptibility to pathogens. Denisovan genes help Tibetans survive in high-altitude environments. Migration created diversity in language, culture, and adaptations. Humans adapted to deserts, forests, mountains, and frozen tundras. They developed boats, tools, and clothing to survive extreme climates. Groups maintained social bonds through shared rituals and storytelling. Cave paintings document hunting scenes, animals, and abstract patterns. Cognitive sophistication grew, enabling planning, teaching, and culture. Humans survived ice ages, volcanic eruptions, and megafauna extinctions. The Toba eruption nearly wiped out humanity, leaving few survivors. Resilience and cooperation ensured survival for future populations. Migration out of Africa allowed humans to colonize the entire world. Symbolic behavior like art and ornamentation spread with humans. Language, culture, and abstract thinking became our defining traits. From Africa to the planet, humans spread, adapted, and innovated. The story of human knowledge begins long before modern times. Then came the Renaissance, changing art, philosophy, and science. But before Europe, the Islamic Golden Age lit up the world. From the 8th to 13th centuries, scholars thrived in Baghdad. Muslim mathematicians invented algebra, solving problems with symbols. They pioneered optics, studying light through lenses to explain vision. Ancient Greek texts were preserved, translated, and expanded upon. Astronomy, medicine, and chemistry flourished under brilliant scholars. Libraries held thousands of manuscripts, guiding Europe centuries later. Fast forward to the 1600s, and the scientific method emerged. Francis Bacon and René Descartes formalized discovering knowledge. Galileo improved telescopes, observing Jupiter's moons, proving heliocentrism. Isaac Newton codified gravity and motion, explaining the universe. Experiments, observations, and reasoning became modern science's backbone. Electricity discoveries sparked intense curiosity in the 18th century. Benjamin Franklin flew kites in storms, linking lightning and charge. Alessandro Volta invented the battery, storing energy like a reservoir. Michael Faraday demonstrated electromagnetic induction, powering motors. These discoveries laid foundations for modern electronics and communication. The 18th century brought massive revolutions in industry and technology. James Watt improved the steam engine, powering factories and ships. Soon electricity transformed society with telegraphs, lighting, and more. The Second Industrial Revolution accelerated these changes exponentially. Steel, railways, medicine, and electricity reshaped cities and industries. The germ theory of disease emerged, transforming medicine forever. Louis Pasteur and Robert Koch proved that microbes cause disease. Sanitation, vaccines, and sterilization practices extended human lifespans. In 1928, Alexander Fleming discovered penicillin, a medical revolution. Millions of lives were saved as antibiotics spread across the world. Scientific progress reached for space with rockets and new ambitions. Just 66 years later, in 1969, humans walked on the moon. Neil Armstrong took humanity's first steps, expanding our perspective. The James Webb Space Telescope launched in 2021, observing deep space. JWST captures light from galaxies 13.5 billion years old. It detects water vapor on exoplanets, hinting at habitable worlds. Meanwhile, quantum physics opened strange and challenging possibilities. Quantum entanglement allowed teleportation of information over 1,000 kilometers. This lays groundwork for a future, unhackable quantum internet. CRISPR revolutionized genetics, enabling precise DNA editing. Inherited diseases could potentially be cured and lifespans extended. Artificial intelligence advanced rapidly, with hopes of creating AGI. Researchers envision machines solving any task requiring human intelligence. In 2022, a lab achieved net-positive nuclear fusion energy. Scientists created more energy than consumed, hinting at limitless power. Meanwhile, humanity faces urgent challenges in climate and sustainability. Cosmology remains mysterious, with 95% of the universe unknown. Space colonization is becoming tangible with asteroid mining for metals. Nations race for lunar helium-3, potentially worth trillions. Private companies like SpaceX push exploration and transport technology. Extremophiles on Earth hint life could survive in alien oceans. The simulation hypothesis challenges reality, suggesting a digital construct. Human knowledge and technology have accelerated faster than ever before. From algebra to space telescopes, breakthroughs changed life in many ways. Islamic scholars preserved knowledge, giving Europe Renaissance tools. Science shows a pattern of curiosity, experiment, and ingenuity. Knowledge preserved through history allows civilizations to build. Every discovery, from algebra to AI, reflects human curiosity. Humanity's journey through knowledge combines exploration and bold experiments. Subscribe and like to follow more incredible stories of science, discovery, and innovation endlessly.